Hey guys, in this video we're going to do two things. One, we're going to slightly improve the player movement that we implemented in the previous video, and two, we're going to make a bullet that basically goes forward at its current angle. So let's get started. You'll notice that in the last tutorial we made the player move like so, right? We had it so that when the up arrow key was pressed, we made him move a little bit up. When the right arrow key was pressed, we made him move a little bit right. So I kind of have this visually drawn. Here would be up, here would be right. Now what if both the up and the right arrow keys were pressed? Well, if both the up and the right arrow keys were pressed, then the player will move here, then here. So in other words, he'll move like this. So he's really moving by that red arrow. Notice that this red arrow is longer than the up and the right arrow, right? So what this means is that the player will move diagonally faster than he will if you're just moving up, down, or right, left. You know what I mean? Diagonally is faster than straight. The reason is because every process, remember that we were moving in every frame. So every time that the process method is called, we're moving a little bit. So since you're moving a little more, if you're moving diagonally, then you're moving faster diagonally, and we don't want that. So the way to take care of that is to basically, what we're going to do is we're going to kind of keep our regular logic, but before we add that move vector, we're going to normalize it. What normalizing a vector means is that you're going to make its length 1. And then once we make the length 1, so whether our move vector is just straight up or if it's diagonal, we're going to make them the same length because we're going to make them both a length of 1. Once we do that, then we're going to multiply that vector. So we're going to multiply that length of 1 vector by the amount that we want to move by. When you multiply a vector by some number, you're basically growing that vector. So I kind of show that over here. So let's say we start with this little blue arrow to the right and we multiply by 5. We would get this bigger blue arrow to the left. So, and conversely, if we started with the bigger blue arrow to the left and we multiply it by a fraction, so let's say 1/5, we would get an arrow that is 1/5 the size. So we would get this arrow to the right. So in summary, normalizing a vector means shrinking it till its length is only 1. Multiplying a vector by a whole number will grow it. So if you multiply it by 2, if you multiply it by 2, it will be twice as long. If you multiply it by 3, it'll be 3 times as long, and so on. And multiplying a vector by a fraction or a decimal shrinks it. So if you multiply a vector by 1/2 or 0.5, then it's going to be half of its length. So also I wanted to note one more thing about vectors. You'll notice that whenever I talk about vectors, I draw them as arrows. That's the best way to visualize them. A vector is really like an arrow, right? And you can think of it as having 2 components. That's why vectors have an x and a y component. So you can think of the x component of a vector as how much horizontally it moves, and the y component of a vector as how much vertically it moves. Because let's say that this is your vector, right? This top blue one right here. This is kind of going diagonally, which means that it has a little bit of a horizontal component and a little bit of a vertical component. So this has both. But if we have a vector like this blue guy right over here, then that really only has a vertical component. So for this particular vector, its x component will be 0 because it doesn't move in the x direction at all. It only moves in the y direction. And this guy moves up in the y direction. So he's going to have a negative y component, because remember, in Godot, negative y is up. And just to hammer the point home, this vector over here only has an x component because it only moves in the x direction. It doesn't move at all in the y direction. So the y component is 0 and the x component is some positive number, because this is going in the positive x direction. And this red arrow over here, this red vector, it has both an x component because it moves some amount in the x direction, but it also has a y component, so it moves some amount in the y direction. Now, so you imagine vectors as like, as arrows. So let's say we have some position here, and we say move this position by this vector. What do we mean by that? Well, we just mean basically take this position and slide it up this vector, right? So if you start with this position and you move it by this vector, you're going to end up here. If you start with the same position but you move it by a different vector, so this vector, you'll end up here. So kind of keep this visual in the back of your head when we talk about moving things. So let me open up our code. So you notice here in our process method, so this is getting called every frame, so some number of times per second, and it's telling you how long passed between the last time it was called. And we use that information to determine how much we're going to move during this frame. Because the longer time that has passed since the last frame, the more we're going to move. That's why we multiply this speed by delta. So we kind of went over this in the last video. I won't spend too much time. But anyways, what we do in the frame is we first decide, we create a move vector, so a vector that we're going to move by, and we initialize that to 0, 0. So we're going to move by 0 in the x and 0 in the y initially. But we modify the components of this vector based on what keys are pressed, right? And then after that, we add the move vector to our position. So in other words, we move ourselves along that move vector. Now, you'll notice from the last time that I changed this code a little bit. So what I've done here is basically similar to the last one. I initialize the move vector to 0, 0. And then when the up arrow key is pressed, instead of making the y, move amount, I just made it -1. I just said, you know what, we're going to move in the negative y a little bit if the up arrow key was pressed. And if the down arrow key was pressed, we're going to move in the positive y direction. So we made that 1. If the left arrow key is pressed, we're going to move in the negative x direction. If the right arrow key is pressed, we're going to move in the positive y direction. So now our arrow points either up if only the up arrow key was pressed. It points to the right if only the right arrow key was pressed. It points to the left if only the left arrow key was pressed. But let's say if 2 keys were pressed, so let's say the up and the right arrow keys were pressed, kind of points diagonally, right? That way. But now we want to make sure that this vector has a length of 1. So that's what we do here. We normalize it. So we normalize the vector, and then we multiply it by the move amount. So this will grow it by the amount that we want to move this frame. And that's the vector that we want to move by. So let's go ahead and run this and make sure that it still works. So let's go ahead and open our scene. It was called player. And click this button here to run it. Okay, here it is. Let's move. And there you go. Now we're going to move at this speed diagonally. We're going to move at the same speed straight. See? So when we move straight, and when we move diagonally, now we're running at the same speed, whereas before we were not. So that's the little slight improvement that I wanted to make to the player movement. And hopefully through that process, you learned a little bit more about vectors, because it's really important to kind of learn how to visualize what a vector is. And like I said, I like to imagine it as an arrow that has an X component and a Y component. And if it's a straight arrow, so if it's an arrow that just goes, just to the right, for example, it only has an X component. An arrow that goes just to the right has no Y component because it just goes to the right. All right, so now the next thing that we want to do is we want to create a bullet. Now let's exit this and let's define what a bullet is. A bullet right now is just something that moves straight. It just moves forward. So what I've done is I created a little bullet image, and this is just a little yellow rectangle, okay? And that's what I'm going to use as the image for the bullet, and we want it to move forward. So create a new scene for the bullet. For its root, just make it a 2D scene. You'll also notice that for every game object that I create a new scene for it. So for example, I created a scene for the player, and I'm creating a scene for the bullet. Whatever I need, I usually create a scene for it. So if I want a car object, I usually create a car scene. You'll see that pattern over and over again. And remember, once again, that a scene can only have one and only one root node. And I usually make that root node a node 2D, which is just a generic node. So for our bullet, just give it a root node of node 2D, and then we're going to give it a sprite Okay, that's going to represent its graphic. And also as a child, remember that Control A is the shortcut for adding a child node. So select it, Control A. Now also give it an area 2D, and I'll explain this shortly. So not area, area 2D. And for the area 2D, we'll go over that later. So for the sprite of the bullet, go to your images, and you can put your own image there, but I made this little yellow thing called bullet.png. That's the graphic I want. That's kind of hard to see, so let's zoom in. You can just use your mouse wheel to zoom in here, and then you can hold down the middle mouse button and move to drag. So there, we see our bullet, right? Okay, so what we want to do is, like we said, a bullet, my definition of a bullet is something that just moves forward. Now, whenever, you have to define forward, because what is forward, right? You have 360 degrees in terms of where you could move to. So what is forward? Well, that leads us into talking about, coordinate spaces, right? So the coordinate space for this this scene, this bullet scene, let's save it first of all. So we're just gonna call it bullet. Now the coordinate space, you see the origin over here, right? So positive x again is to the right, positive y is down, okay? So I'm gonna define the positive x-axis of the bullet as its forward. So let's twist this bullet a little bit. We're gonna select node 2D, we're gonna go to the transform, and for the rotation, we're gonna mess with this. See, we're changing it. So I'm gonna make it about 40 or so degrees, so 40 degrees. So now, still, the positive x-axis of the bullet is this way, and the positive y is that way, okay? Because this is the root. So what we want is, we want the bullet to always move towards its positive x-axis. So let me write some code to do that really quick. So first of all, let's attach a script to our bullet to give it some behavior. So click that button, call it bullet.cs, make sure it's C#, create it. Now let's edit the code. I like to use VS Code, so let's jump to that. Let's delete all of this template generated code. And now we want to move the bullet forward. And there's several ways you could do this, but right now we already know one way to move things. That's the process method. And that's how we move the player, right? In the process method, we detect what keys are pressed, and based on what keys are pressed, we move him. So we're going to use the process method to move the bullet, but the bullet, we're not going to move him in response to any keys. We're just going to move him, all the time forward. So let's zoom in a little here. Okay. So let me actually go ahead and write all of that code so I don't waste your time, and then I'll go over it after I've written it. Okay, so here's the code. Just like before, whenever you want to move something in the process method, so every frame, first thing you want to do is determine the speed, right? So how fast does this thing move in pixels per second? And then based on that delta and your speed, you're gonna find out how much you need to move during this call to the process method. In order to have this speed, during this call of the process method, I need to move this much, right? So you're seeing a pattern. We kind of did the same thing when we're moving the player. So we know how much we should move by, and then I just get the direction that we should move by, and I multiply that direction, which is a vector, by this move amount, and then we basically move our position by that vector. Remember that what I said earlier, what does it mean when you move an object or a position by a vector? It means take that position and slide it up that vector. So visualize that as I'm explaining this, okay? So this, let's zoom in on this a little bit. So we said that we want a bullet to go forward, right? And we define forward as the positive x-axis. So how do you get the positive x-axis of the bullet, this object? Every node has a transform property. And the transform property gives you both the x-axis and the y-axis. So the x-axis is .y. So if you do transform x, you're going to get the bullet's x-axis, right? And then we're going to normalize it. This is, I believe, normalized, but I do it just in case. So I want to normalize it because I want it to have a length of 1, because I only care about the direction. I don't care about the length. So once I make it a length of 1, then I multiply that vector by the move amount. So then imagine me enlarging that vector to be, 200, like whatever we need to move. So let's say if we needed to move 10 pixels this frame, then we're going to make this vector, which is 1 pixel long. When we multiply it by the move amount, we're going to make him 10 pixels long. So kind of visualize that. All right, let's go ahead and run this and see what happens. So we're going to run this scene. There you go. You see that the bullet just keeps on moving forward endlessly. All right, now the next thing we want to do is we want the bullet to have a maximum range. So we don't want it to move endlessly. Once it has moved a certain distance, we want it to basically be deleted. All right, so let's go ahead and do that. Now, in order to do that, we're going to have to keep track of how much, what's the maximum that this bullet can move, and also how much it has moved. All right, so public float max, I'll just call this range. So the range is going to be how far this bullet can move. We're going to make this one only 300 pixels. So we're going to say pixels. All right, 300 pixels. We don't need to put that comment. All right, and then we're going to make a private field that's going to be distance traveled. That's initially 0. So initially, the bullet has not traveled at all. So what we're going to do is after we move the bullet, we're going to update the distance traveled. So distance that the bullet has traveled, increment that by how much it traveled by. It traveled by move amount. We already know that. And then we're going to say that if the distance traveled is greater than the range, so if it's moved enough, we're going to delete this bullet. And the way that you delete nodes in Godot is by using the queue-free method. Don't use free, use queue-free. We'll go into more detail about this in later tutorials. For now, just remember to use queue-free to delete nodes in Godot. So this kind of makes sense, right? Once we move the bullet, we're going to update the distance traveled variable. And then we're going to see if the distance traveled is greater than the range, so the maximum that the bullet should move, then free the bullet. So let's see if this works. Well, let me make sure I save. There you go. So it just moved a little and then it deleted itself. So let's make the range 100 and verify that this really is working. There you go. Yeah, it just quickly deleted itself. Okay, so now we have this bullet object that just moves forward at its current angle. So what we want to do next, so we haven't handled any collisions yet, but you know what? Let's handle the collisions next. So what we want is whenever the bullet collides with something, we want to know that it has collided with that thing, right? For now, we just want to know that it has happened. Later, we can, delete that thing that it has collided with or subtract its health or whatever, right? So whenever you want to know when certain things have collided in Godot, there's a couple of things that you need to understand. So you know that everything in Godot is a node, right? Everything inherits from the node class. Well, you can't detect collision across all nodes. What I mean is you can only detect collisions with nodes that inherit from physics body or area 2D. So if you want collision, just remember that you can only detect collision between physics bodies or area 2Ds and no other nodes. So that's why we gave this bullet an area 2D child so that it can participate in collision detection. Now that means that he can only detect if he has collided with other area 2Ds or physics bodies. You can't just detect collision with things that don't inherit from area 2D or physics body. We'll talk about physics body and collisions much more in later tutorials, but for now, this is all you need to know. All right, so for an Area 2D, in order for it to detect collision, you need to give it a collision shape child. So click it, add a child, and do collision, search for collision shape. We're gonna choose this one. Okay, for the collision shape, this may seem kind of redundant, but you need to choose a shape. So click this drop down and you can choose a capsule or a circle or just a general polygon. But for our bullet, since it's kind of rectangular, we're just gonna choose rectangle. And now you see that blue, that's the rectangle that the bullet will collide. So that's the bullet's like physical thing, right? That's the thing that will collide. You can use these handles, these little red dots to resize it, or you can click here and then use these extents. So the X is the width and the Y is the height. I'm just gonna use the handle, so watch. I'm just gonna drag it, make it the same size as the bullet. And same with this one. There we go. So you can use, you see these little eyes next to your nodes, those will toggle the visibility of that. So watch, when I make the Area 2D invisible, I see the yellow texture of the sprite. And when I make it visible, I see the Area 2D's collision shape. So that's the physical shape that will collide with other Area 2Ds or physics bodies. All right, so we have a bullet. Our bullet has a sprite for its graphic and it has an Area 2D with a collision shape so that it can detect when it has bumped into other Area 2Ds or physics bodies. So now what do we do in the code? There's something that we must do as well. So we have to listen to the Area 2D because when the Area 2D collides with other Area 2Ds or with physics bodies, it emits a signal. So now that brings us to signals and slots. All right, so let's quickly discuss that, and we'll go over this again and again in future tutorials. A signal, when something interesting happens to nodes in Godot, they emit a signal, and the different nodes have different signals. What you can do is you can attach methods that get executed when a certain signal on a certain object is emitted. So let's make this concrete. The Area 2D object, whenever it collides with another Area 2D, it emits a signal called area entered. When it collides with physics body objects, it emits a signal called body entered. And you can look at the documentation for the Area 2D. Actually, let me show you that really quick. Okay, so if you just Google Godot Area 2D, you're gonna, and you click on the first link, you're gonna come to this page. This tells you a little description for the Area 2D, what it inherits, etc., and its any tutorials on it. Also, its properties, methods, and signals. Right now, we're interested in the signals, right? So you'll see that the Area 2D has an area entered signal, which is emitted when another area enters. It has an area exited signal, which is emitted when another area exits. So you'll notice that both of these signals have a parameter. So they're gonna tell you the area that was entered or the area that was exited. So those two signals are of interest, but also these two. Body entered is when a physics body enters it. So not an Area 2D, but a physics body. Body exited is when a physics body exits it. So just remember these two, basically the area entered and the body entered is what we're interested in right now. All right, so what we want to do is we know that our bullet, right? Our bullet, this is our bullet. It has an Area 2D child, and we want to connect a slot, so a callback. We want one of our methods to be executed when an area or a physics body enters this bullet. So in other words, when the bullet collides. So let me go ahead and do that. Let me make that connection in the ready function. So there's a ready function. This you can think of as like the constructor of your node, but it's not really a constructor, and I'll basically give you the real answer as to what it is later. For now, you can think of it as a constructor. Okay, so let me write the code here to connect to our Area 2D's area entered and body entered methods, and then I'll explain it. Okay, so what do we do on the constructor, in a sense, of the bullet? First of all, we use this line of code to get a reference to the Area 2D child. So you can use the getNode method of any node, and then you pass it a string with the name or the path of your child. So what I mean by that is, let's say I wanted the collision shape, right? You'll notice that our script is attached to this guy, right? So everything is relative to this guy. So what's the name of sprite relative to him? It's just sprite. What's the name of area 2D relative to him? It's just area 2D. What's the name of collision shape 2D relative to him? Well, that's area 2D / collision shape 2D. You can kind of think of the names of these things as the way that you work with file paths, right? So that's kind of how they work. So let me show you an example. So if I wanted to get a reference to the collision shape 2D, I would use the getNode method, and here's the path that I would pass. I would do area 2D / collision shape 2D. So I hope you kind of get that, and we'll be doing this more and more, and it'll sink in. But right now we just want a reference to the child name area 2D, so we get that, and then we connect to the area entered signal. What do we connect? What method do we connect to? Well, the method is in this object, and the name of the method is onCollision. We connect the same method to the body entered signal. By the way, the method that you're connecting is often called slot. So here's the definition of that method. All we're going to do is print that the bullet collided with something and then free him. Okay, so we can't test this just yet. We're going to be able to test it later, but not just yet. So we've connected to the area entered and body entered of our area 2D. Right now, all we do is when the bullet collides is we print something out and then we delete the bullet. So first of all, what we want to do before we can test this is we want the player to fire every time the left mouse is clicked. We want the player to fire. So there's a method that we can implement in the player that gets called whenever events happen. So events are things like when the mouse is pressed, when the keyboard is pressed, stuff like that. And that'll tell you information on what key is pressed, if it's a key press, what mouse button was pressed, if it's a mouse press, etc. So what we want to do is whenever the mouse button is pressed, we want the player to first just know that it was pressed, and then we'll take it further and we'll actually shoot a bullet when the mouse is pressed. So first I just want to, in the player, when he detects that a mouse was clicked, right, we just want to print something. So let's see if we can get that to work. Let me write the code and then I'll explain it to you. Okay, so every node has this unhandled input method. And when an event happens, so for example, when a mouse is clicked or when a key is pressed, that event, right, that event will be passed through as a parameter to every node's unhandled input. So if you have a bunch of nodes in your scene, it'll be passed to every node's unhandled input. And the first node that handles it, then it'll stop getting passed around. So what do we do in the unhandled input of the player, right? So when the player is past that event, so let's say it's a click event, first we're going to make sure it's a click event, right? So we're going to see that if the event is a mouse button event, and if you're not familiar with this C# syntax, that's basically, it's saying that if this object, this event is, if it derives from this class, then name it this and execute what's inside my if statement. So that's what it's doing. So we're seeing if this event is a mouse event, right? And then we're seeing that if it was the left mouse button that was pressed and it was actually pressed and not released, right? We are only interested when the mouse is pressed, not released. If all these conditions are true, then we're just going to print something out and we're going to mark the event as handled. This is what this line does, so that the event doesn't keep getting passed to other nodes because we handled it. So let's save this and let's test. So this is the player. We're going to test the scene. And so we're going to move it here. Now watch the output over here when I click the left mouse button. So see, player detected it. Player detected it. Watch when I press the right mouse button, it shouldn't print anything. Nope. Okay, good. So now the player actually detects when the left mouse button is pressed, but we don't want to just print a message, right? We don't want to do this. We actually want to spawn a bullet. So let me write the code to do that, and then I'll explain it. All right, so I've done that. So the first thing that I did was I declared a packed scene variable as an attribute of the player. And a packed scene basically represents a scene that has been loaded into memory. Now, you haven't created an instance of the scene, but you've loaded to memory. That's what it represents. So what I do is, and the ready, which is, again, you can kind of for now think of it as like the constructor of the player, right? The ready is like the constructor. So what we do is we initialize that the bullet scene, right? So we load the bullet scene. We pass basically a path to the bullet scene. So remember again, res : / means the root of our project. Go to the root of our project and then bullet.tscn, which is right over here. That's the scene for the bullet. We load that into a packed scene, and then when the player detects that the left mouse was clicked, we actually instantiate an object of that scene. So we create an actual bullet. That's what we do over here. So to do that, you just call the instance method of the packed scene. So we have the bullet. Now we give the bullet the same position as the player because we want it to be at the same location as the player. And we give the bullet the same rotation as the player. So it moves in the same direction that the player is facing. And last, we actually add the bullet in the scene. So here we get the parent of the player. So we say wherever the player is in, whatever parent the player has, we want the bullet to have the same parent. So we get the parent of the player, and then we add the bullet as a child to that parent. So now the bullet and the player are siblings, in other words. And that's all. We replaced the printout with these lines of code here. So let's go ahead and see if this works. So let's move around, and now let's fire. There you go. Remember, we made the range of the bullet very little. Let's go ahead and modify that. So go to the bullet and range, let's make it like 400, and the speed, let's make it like 400 as well. The last thing that I wanted to do was show you when the bullet actually collides with something. So for that, let's create a new scene that represents the world as a whole. So for the root of this scene, we're also going to put just a 2D scene, just like we do for every other scene. I mean a node 2D. And then go ahead and add the player. So to add another scene as a child of a node, it's a little different than adding child node, right? So you select your scene, and then you click this little link icon here, and then you select the scene that you want to add. So we want to add the player, and then that's it. We just want to add the player for now. Let's save this scene. Let's call it main. So this is our main scene, or your whole world. Let's run this scene and make sure that we can still move the player around in this scene. We can, and we can still shoot. Okay, now let's put a little block or something that the bullet collides with, and we get a printout message, and the bullet deletes itself. Because remember, when the bullet collides, we print out a message and queue free the bullet. So let's verify that actually works. So click on your root node in your main scene, add a child node. Here we're going to add another area 2D for the bullet to collide with. And let's give it a sprite so we can visually see the area 2D. And also give it a collision shape to define the shape of the area 2D. So for the sprite, we're going to choose just this icon.png that every new Godot project comes with. And then for the collision shape, we're going to do new rectangle shape. Then we get those handles again, and we're going to go ahead and make it the same size as the picture. Okay, now we're in our main scene, so we're going to get this area 2D, the whole area 2D. Oh, not the collision shape. So you notice that my goal is to try to move this whole area 2D, but when I click over here, when I click and drag here, it just selects the collision shape 2D because that's the thing on top of everything else. So there's a trick to preventing this. Select the parent, and then you click this button, which says make sure the objects are not selectable. So if I click that, you see this little icon appears. It means this node's children will not be selectable in the scene editor. So now when I click and drag, I'm moving the area 2D, you see? So let's put the area 2D somewhere right here. Let's rename this to a wall. So remember I went over this in the first tutorial, but when you're adding nodes in your hierarchy here, right, they have a type and a name. Each node that you add has a name. What you're seeing here is their name. You can see the type by moving your mouse over them. See? The name is wall, the type is area 2D. So let's go ahead and run this. Let's shoot at the wall. So first of all, we'll shoot down here. You see the bullet goes, pretty far. Let's now shoot at the wall. And the bullet destroyed itself and we got a message bullet collided. So now we got a little wall. And that's it for this tutorial. So remember, again, always look at the description of these videos because I'm going to have, I'm going to first of all upload the code. Of course, I'm going to upload slides so that you can use the slides as like a review or a summary or a reference for what you learned. And I'm also going to link to other videos that I've made on Godot that reinforce the concepts or expand on the concepts that we learned here. So definitely look at the link in the description. So that's it for this video. Bye bye. See you in the next one.